All right, the topic is global warming, coming ready or not. And so the poster child of global warming is the polar bear in the Arctic with decreasing ice, and the poor polar bear is crying out for help. So the IPCC was mentioned, and indeed the IPCC, the Intergovernmental Panel on Climate Change, has received the Nobel Peace Prize along with Al Gore, and was in that order, by the way, the IPCC and Al Gore. The newspapers forgot about the IPCC to a very large extent. And if you like to ask questions about IPCC and its nature, I'd be happy to answer those, but I haven't included them in the talk itself. But the main conclusions of the recent report, especially the part that I was involved in, which deals with the science of climate change, is that warming of the climate system is unequivocal. I'll say a little bit more about that later, and is very likely caused by human activities. And moreover, now most of the observed changes can be simulated by climate models over especially the last 50 years, which adds confidence to future projections. So I will show you some aspects of the basis for these conclusions as we go through this talk. The thing I like to do in starting a talk like this is to emphasize the global aspects of the problem. You may have seen this little balloon go across here, and indeed a few years ago we had balloonists, man balloons, attempting to go around the world, and if you follow those, you will see that about 5 days they're about halfway around the world, 10 days or maybe as much as 2 weeks to go all the way around the world. And so the air that's over the United States one day is over Europe a few days later, and a few days later it's over China. Or the air that's over China is over the United States say 4 or 5 days later. Which means that the atmosphere is a global commons. There's one other global commons, which is the ocean. And there is a law of the sea, so-called, that treats the oceans as a global commons that belongs to everyone. There is no such law for the atmosphere. And so what we do, of course, is we dump all kinds of stuff into the atmosphere, all kinds of pollution, without any penalty whatsoever. And some of that stuff that we dump into the atmosphere lasts a long time. A lot of the visible pollution that we dump into the atmosphere from burning actually gets washed out very quickly on a time scale less than a week. But carbon dioxide and other gases that we put into the atmosphere can last a long time. Carbon dioxide over 100 years. And so it builds up over time, and one of the consequences is global warming. This is part of the record of carbon dioxide as seen at Mauna Loa, started by Dave Keeling back in 1958, and there's a sawtooth character to this record. That shows you the natural annual cycle as the northern hemisphere greens up in the spring, and in the summertime there's a drawdown of carbon dioxide in the atmosphere, and then as the leaves on the forest floor and so on decay in the fall and going into the winter, there's a buildup of carbon dioxide again. And so you can see the amplitude of this natural annual cycle, and by looking outside you can get an idea of the magnitude of the change in the biosphere associated with the seasons, how large that actually is. But superposed upon that we have this overall trend. There's a few little wiggles in this trend. Some of those are related to things like El Nino, but this overall trend here is related to more carbon dioxide going into the atmosphere from the burning of fossil fuels. And so we're currently over 380 parts per million by volume. The estimate of the pre-industrial level, say about 250 years ago, is 280 parts per million by volume. And that's pretty well known and very well established, and it was stable for 10,000 years. And we can get that out of little bubbles of air that are trapped in ice cores. So we know what the pre-industrial level is, and so we've increased by over a third, by 35%, 36%, from what the pre-industrial concentrations of carbon dioxide are. And we know that carbon dioxide is a greenhouse gas. Just as a little aside, most of the atmosphere is made up of oxygen and nitrogen, O2 and N2, two atoms per molecule. A greenhouse gas, an easy way to tell a greenhouse gas is just about any gas that has more than 2 atoms per molecule. H2O, water vapor, nitrous oxide, carbon dioxide, CO2. And it's the way those atoms can bounce around and vibrate and rotate that enables them to act as a greenhouse gas and absorb radiation and then re-emit it. And so it plays a role in the heat budget of the climate system. Where does the carbon dioxide come from, this increase? The main thing, because carbon dioxide has a long lifetime, the main thing that's important is the total amount that we've actually put into the atmosphere. And this is where the so-called rich countries or the developed countries play a key role. So Europe has played a major role. The U.S. is the country that has contributed the most overall. The rest of the world is up here, and there's a few countries down here. Notice India, 2.4%, China, 7.6%. It's hard to read from here. A lot less. And you'll see right now in the news there's a lot of debate about these. And the reason for that is because this is the emissions in 2004. The U.S., this is the whole pie, of course, and what's really happened is that the whole pie has gotten a lot bigger, but as a result, the U.S., even though it's increased, has gone down to about 21%. Europe has dropped from 31 down to 18%, a lot more. China has gone from 7 to, 16.7%, and India has also doubled relative to its historical contributions. And it's the rate of these increases that are of concern. In fact, the estimate in 2007 is that China will pass the U.S. in terms of the total emissions that are going into the atmosphere. So the Chinese have every right to be concerned about what the U.S. has already done to the atmosphere, but by the same token, you ought to be very concerned about what the Chinese are now about to do to the changing composition of the atmosphere, and the Indians and so on. And I think that what has to happen as a part of this is some sense of outrage. I'd like to see more of a sense of outrage that we're changing the composition of our atmosphere, and it's going to have consequences. So what are those consequences? Well, this is another way of looking at it, actually. Here I've just dividing it up in terms of population versus the amount per population, per capita. And so I've highlighted 4 different regions here. One is the U.S. The U.S. leads the world in per capita emissions. Western Europe is down here. Western Europe has a similar standard of living, but the emissions per capita are around about 2.5 times less than the U.S. as a whole. China's down here. At this time in 2000, China was 1/10 per capita of the U.S., but they have a lot more population. So it's the total area that matters. And India also have a very large population, and they were 1/20th. And so the Chinese and the Indians are trying to increase their standards of living, increasing the amount of energy that they can provide to their people, so they have refrigeration and heat and so on, things that we take for granted. Very admirable goals. But one of the issues then is the population. What happens if they have the same standards of living, if you like, and other wasteful practices like we have in the U.S., and this goes up to here? Something worth thinking about. So population is one of the issues which is not really talked about. Another, why is this so much less in Europe? And if you've been to Europe, you'll know that gasoline costs probably $8 a gallon now. It used to be about $6, but the U.S. dollar's gone down and the euro's gone up. And electricity is more, and so they have smaller cars and they do things a bit differently. They use trains more and so on. If we look at the U.S. by itself, here's the U.S. as a whole. California is almost half the average of the U.S. I don't know where Alabama is on here, but Texas leads in the U.S. The largest amount per capita.